Yesterday when we discussed about pointer, we missed one thing. Pointer of pointer, right? We didn't cover that one in example, right? That means a pointer can also point in another pointer. We are going to see the example today, how to work with pointer to pointer. From there, we can proceed to the next topic. Okay, now. So for that, let me create a program and plus e pointer. Right. So here, initially, as usual, we used to declare variables. I declare int k equal to 450, and then int ptr equal to address of k, right? Then we have another variable int pptr is equal to, I believe this time we can directly say ptr. No, I believe it is star ptr. So this is the actual memory address. Right, those k will have a memory address in stack. There 450 is stored. That we all know because all these things are auto scope, so it will go there. Where this star ptr and star ptr will be stored. Come on.
In stack only.
Stack only. They will also have the address in stack. Okay. Then when we have in the memory location of k, we have 450. In the memory location of ptr, we will have the address of k. Right. The address of k will be there in the ptr. In pptr, that is also a locations in stack memory. That location, actually it has an address. The PTR has an address, PPTR also has an address, right? So in this address, the content of that address in K, content of K is 450. No, like that, the content of PTR is address of K. Content of PPTR is address of this PTR. Right. Let us demonstrate that. First, we have printf address of k, that is first thing, is equivalent to ux comma we have address of k now. So right, then printf address of ptr is equivalent to, so as it is, just we have to say ptr right? Correct. So once we get that, we can understand. Let me compile and run this program. Very interesting. P pointer.c. Here is a file now.
Yes, sir.
Pointer.c. Okay. Let me type dir.
There's 208.
Yeah, it is there. But why it is throwing error? P pointer.c. Okay, I think here we have a mistake.
Okay.
So warning, initialization makes pointer from integer without casting. Int pptr is equivalent to just ptr. Initialization from incompatible pointer type. Why? pptr equivalent to ptr.
Star pointer equal to star pointer, right? Or
This is what we had. Actually, as it is a pointer variable, we need not, when we point
okay.
it, we don't need to specify the star. Maybe. I'm not sure whether this will work or not. Interesting. Brilliant. So, but we didn't print the address, right? No? Did you print that? Address of K we are printing, and then content of PTR we are printing. Actually, yes. Content, the address of PTR, address of PPTR we are, but we are not printing the content of PTR and content of PPTR as well as the content of K. So that is not printed. Okay, we will do that. First, let us check this. It should be 3 different address, right now.
Yes, sir.
P pointer. Right. So it is 96, 2296, 2292.
Yes, sir. Correct.
How it is correct? See, 642296. This is address of K. Address of PTR should be a different one, no, because it has its own address.
No,
But
sir. We are printing the value of PTR. Right? Or
no, our aim is to know the address of PTR. Okay, maybe I think we have to do like this. We want to know the address, 3 different, because they are 3 different variables, right? We want to know their address.
yes, sir.
So if that is the case, they should have 3 different address, 300, 96,
92.
92. Perfect. They are 3 different address. So this gives us address of them. Now we are going to see the content of them. Right.
Okay. If only we are giving the only the PTR means it is taking.
Actually, when we give a PTR, it takes the content.
Okay.
Right. PPTR means the content of PTR will come, I believe.
Okay, then
Right. So
address of PTR will be there in that content.
yes,
Yes, sir.
right now. So now we copy paste that and we say content of K. K is actually all are unsigned numbers only. So what we can say is UX unsigned number. Just we print
K.
K, PTR, PPTR, right now?
Yes, sir.
So that will print their content. Okay, let me do in this way. That would be more appropriate because it's a little bit confused. So the content of K is 450 and the content of PETR is address of K, which is 642300. Content of PPTR is the address of PTR. Right now, it works right. So it works as per this. Now the problem is, see how the things are going in a different directions. See here, when we use K, it printed the content right now.
Yes, sir.
Right. I want to increase K. What I have to do? I can say K plus 1. When I want to increase the content of PTR, what I can do? Can I do PTR plus 1? Will that work?
Yes, sir.
You think it will work?
Means
I want to increase the content of PTR, not the address of PTR.
okay, value of PTR.
Hmm.
So value of PTR is
So
address of K.
let us try this. See, we have to be a little bit cautious when we work with pointers. That's why I made mistake before. So just I copy this and paste it. Right. So increase, increment. I'm just increasing. Content of K. If I want to increase the content of K, I can say K plus plus. Right. If you want to increase the content of address of content, increment content of PTR. I can say PTR plus 1 right now. So that particular address plus 1. So here I say increment content of PPTR. We can say PPTR plus plus. We can do like this also. So after we execute these three things, K should be that is K should be 441. Sorry, 451, and PTR should be the next address to K. What is the next address to K? Which means that it will do 4-byte offset, right? And PPTR will be again a 4-byte offset. They will create a 4-byte offset, right? Let us check whether that really happens. So just to save that and I run it. Very interesting. Okay, probably they are printing because this is post increment, no? We are printing the post. Actually, after they print the K, they will increment the K. Like that it will be. So let us do a pre-increment. Right. So now, okay, 451 pointer PTR, the content is currently the increment content of PTR plus only we gave, right? Actually, PTR become
Yes, sir,
content.
correct on.
One
8
second,
bits it has taken.
give me a sec. 304, no. Why they increment 8 bit? That is a question. Address of PTR is that one. We just increment the PTR plus one only, no? PTR plus plus PTR. Plus PTR means its address should be increment to the next level, which means that whatever the address it has, from that we have to add four bytes. Right. That is what the expected result. So
Yes, sir. But it has taken 8 bytes.
8 bytes.
Both have incremented 8 bytes.
8 bytes. 92 becomes 300. 96 become 304. Actually, okay. Their address, this is their address right now. What is their content? Their content is content of PTR is 96. Content of why we have all, there is no content, right? Only we are saying content of K. Other two things are, it is content actually. We didn't update that. Okay. So the content of K is 450. This one is 300. From 300, it went to 304. That is acceptable. See, your plus increments its content, not its address. Do you understand? Actually, plus see, when we want to know the address, we use this. Want to know the content, we just use this one. When we say plus PTR, it increments the content of PTR, whatever the content it has, right? Actually, the PTR has its own address. Pointer is its own. They don't touch it. Whatever the content that we have in the PTR, that is incremented by one step, which is nothing but adding 4 byte to its content. The content of PTR that we got here is 300. 300 become 304. That is correct only, no? Then the content of PPTR is 96, which is incremented to 300. Perfect. So here
The address of K is incremented, right, sir?
at
Means, at
see,
the
value of the K is incremented. Value of the K is incremented, so it becomes 451. Value of PTR is incremented, that's why it becomes 304. PPTR is incremented, that's why it becomes 300.
Yes, sir.
But K has an address, PTR has an address, PPTR and an address. Those were not disturbed. Does that make sense?